So hi everybody and welcome back. This is our C++ tutorial series for absolute beginners. This is video 197, and in this video we continue with our new expression, but we learned the second keyword, which is delayed, which we have to learn in combination with the keyword new. Let's click on delayed, and you can see delayed expression and delayed allocation function are similar to our new. We have here a delayed expression, which we will use in a moment. The syntax, this is the normal syntax, array syntax. And you can see here's also the operator delayed, which will be called by the delayed expression. So we are not calling this one. This will be called, but this you can overload this one if you want. But we as a starter, we don't want that at start, at least not at start. And there is another delayed function which we skip. We are clicking here this delayed expression, and here we try to understand just the first sentence. It says here destroys objects previously allocated by the new expression. You can see that means if you have used an allocation function, which we did in our last video, that was this example here. I created here a pointer, and this pointer holds my new expression here, which was new int, and I showed you this diagram. You can see this pointer here, this new expression is this here, created here with this pointer here, which is a void pointer, and this pointer we had to assign to our L value pointer. L value pointer means a fixed safe pointer which we can call. That's why we created our fixed pointer, and when we assign this pointer to this pointer, our pointer is now pointing to the same place where this was, so we have access with our pointer to this one. And now when we go back to this expression here, means we can destroy this object, but destroy means here release this this memory here. This is active releasing this memory here, and when we read it, it says here allocates by the new expression and release obtaining memory area. That's the important part. So the object is destroyed, which means yes, what we have created, it's destroyed. All right, that's normal, but important is this area is released. And like I said, when you use the new expression, which we have used here, this one here, which means we are using the heap, then you as a programmer have to release this area. And if you don't release this area, when this program exits the scope, the compiler, he will destroy this pointer. And destroying this pointer means here, chuck, the pointer gets destroyed. We have no access anymore to this area, and that's why we have to release it before the compiler is going out of the scope here. And that's our job. So that's why we learn here this delayed expression, and it's very easy. You can see we have just this syntax here. The other syntax is for array. This here is for normal syntax, and let's use it. So, and like I said, when you use the first, when you use, for example, this new expression, this new, and create a variable with new, then all time at the same time write delayed to something like this. It's very, let's write the syntax first here. Here is the syntax again. Let's follow the syntax. What you have to do, this is again optional for global space. We can skip this and write just delayed. And then write the expression. The expression in our case is the pointer which we created. Okay, pointer 1. And you can see that's it. When you do this one, it is exactly doing that what it says here. On the first slide, it destroys the object, so it destroys our pointer 1. And the memory area is released, which means this area, you can see the pointer 1 here, my pointer, this is the pointer 1 here, is now, when you call this delayed, it's releasing first this one, and then it's destroying this pointer here. And that's very important, because if you destroy first the pointer, you have no access more to this place. You can't release that. And that's why you hear many times you have to use this in combination. But of course, careful. When I say you have to use this in combination, means not you have to write it exactly below that, because you create this variable, use first this variable. For example, I use this, and this delayed is most time before you go out of scope. So you should write this delayed pointer most time before you go out of scope. So you can see this scope, this pointer here, what I created here is here with new, and this pointer is going out of scope here. Then I have to write delayed before that, because probably I will use here this variable, right? So for example, let's use this variable as the day say out, then write this pointer, and we have to deference the pointer because I want to print out the value. Let's write pointer1. So here I'm using it. When I do this one, all is fine, but of course don't do this one. This is not fine. When you do something like this, that causes big problems. And you can see here we have deleted this one, and we have an exception. And when I click it on it, access violation, access, yes, we have deleted it, we have destroyed it. So careful about this one. And when I say careful, that is a very important word here. The point is this delayed here and this combination cause many problems in general. And that's why I showed you here, not here actually, I showed you this one in the new keyword. So when we go here, new, go to new expression, and yeah, that was here in storage duration. And in storage duration, this dynamic storage duration, this caused big problems, because what we do here is called dynamic storage duration. We as a programmer are responsible for this storage. So we are creating here the storage. That was that. We are releasing the storage. That was releasing this place and then destroying the pointer, and this caused big problems like I mentioned, right? And that's why they have this, I showed you this in the last video, this special libraries, this dynamic memory management, and there are different solutions to manage this kind of stuff for different use cases. But important is you can see there are different ways. Here are pointers, here are helper classes, here are smart pointers, and so on. And important for us is, as a beginner, normally we have to learn these smart pointers. And the reason for that is these smart pointers manage this delayed function automatically for us. For example, let's click here on this unique pointer. Let's don't care about this template, we have not learned this, but let's read what this first sentence here means. It says that the unique pointer is a smart pointer that owns and manages another object through a pointer and disposes of that object when the unique goes out of scope, which means they are managing it. So the smart pointer will manage our pointer, and when this one, our pointer, with other words, this pointer is managing the pointer which we created, and this pointer, when this pointer goes out of scope, that will handle then this delayed function automatically for us. And this thing is normally very good for beginners, because beginners will mess up here more than advanced people, but even advanced people would mess up here as well. And the reason for that is later when you have here between this creation of this pointer and going out of the scope, when you have here millions lines, millions, but when you have here a lot of lines of codes which are doing whatever they do, it can happen that it causes problems, you are forgetting or something like that. And yeah, it causes big problems with other words. But for us beginner, it would be better that we learn fast this one here and use these pointers here. The problem is, like I said, we have to learn first template. And template is again a big topic. We will talk about this, but keep this in mind. You should use not really this kind of stuff, but you should understand this one. At start we will use it, but this one is very dangerous, and how dangerous this is I won't show you here after we finish this. It's by the way, it's here in the new expression. I showed you this in the last video. There is a section memory leaks, and they showed only 3 memory problems. Let's go fast over the problems here and then go back to Delte, and then you understand why it's very important that we avoid this kind. The first one here is, you can read here, of course, what it says here. You can see when you are not using this anything with delayed expression, then this kind of problems can cause. The first one here, we are just creating a normal like we did. Here's our expression. We assign it to a pointer. This is exactly what I did here as well. They did it only in 1 line, so I did it in 2 line. Most time they will not do this 2 line version here. They will do it in 1 line, because why? When you know you are creating a new variable, then just assign it directly to it. So that's what they do, and that is what we will do as well. I showed you only this step by step here, and here what they show now is if you set the pointer to a null pointer afterwards. So what is that meaning? So here I create this, oh no, sorry. Here I assign my expression. Let's see the variable here. Here, the expression is this here, this pointer. And this one I assign to my pointer. So my pointer is pointing here. And let's go here to this one. No, let's go here this example, and if you set this pointer to a null pointer, what happens is this pointer you are setting to, it's pointing nowhere before you have not released it. And in my example, let's go to this example. So what they mean is, you create this one here, you are not releasing it like here, and before that, before this release point, you set my pointer 1 equal null pointer again. And this one will cause a big problem, because this storage place is no accessible, because this pointer you set it to null pointer. Null pointer, it points to null, to a specified place, which indicates it's a null pointer. But important is this access point is gone. This one stays all time occupied, and I don't know if this is causing a compiler error. The bad thing, it's not causing a compiler error, because this one is not indicating that there is a problem, but we have a memory leak. This is called one of these memory leaks. So let's get first rid of this one. I don't want to have here a memory leak, because that's, you can make this one, but important is after delayed. So if you do this after delayed, there is no problem. That will be okay, because now you release this memory. Now you can use the pointer again for other things. You can set it to null pointer, and then you can assign this pointer again, which you created here for other purposes, right? So the pointer is usable again for other purposes. The object is only destroyed. The pointer is still there. All right. This is, I hope you get this, that you have delayed first. That was our first leak. The second leak is that what I already showed you in my case, that was with the scope. I said when it goes out of scope, the compiler is again destroying here this pointer connection, right? And then we have again a memory leak. That's why we have to use this delayed. That is the second one. And here they show it with a function. Of course, you can see a function has also this scope here. This is the function scope, the local scope for this function. In my case, I made a block scope. And careful, there are millions of scopes. You have all time to check in which scope you created this this new expression here. And the last example is here. Okay, this one is really hard to counter sometimes through exceptions. We talked about exception. Exception means something you see they create in a function, this expression, right? This variable p, which is an int with the value 7. All right, and then they call a function, and this function you can see here throws an exception. And we talked about exception. If an exception is thrown, this function scope is left immediately. And look what happens. They have made it right. They have set delete p here, but because here was thrown an exception, and depends how this exception is handled, this one will leave this body here. It will not go to this point, which means this here is again not freed, and we have again a memory leak. And that's why exceptions, you have to be careful how to handle exceptions with when you have created here this memory with this keyword, variables with the keyword new. And this one is a little bit annoying and happens a lot and cause a lot of problems. That's why we have to use this memory management and some better solutions, because this one, yeah, can cause big problems. And the biggest problem is because you think, hey, I used the delayed pay, like I showed you here. I have created here the variable, right? I used the delayed expression, right? And then you wrote here code, and there is an exception, and then you have a big problem, because this delayed was never called, and you as a programmer are responsible to react to this one again. How to manage this, right? All right, let's go a little bit back. That was here why delayed is so important and what problems is there. Now you see, even if you write delayed, there is a problem, because this exceptions make still problems, and you have to read this a little bit how to handle this one. And in our case, I will go a little bit further and talk about arrays now. It's similar to this one, and the only difference is that you have to use this array symbol here. And let's make here a fast array example, because that you see this as well. Of course, you can do all that what I explained here with normal variables to do with arrays as well. So instead of using let's go here, we create our pointer. The pointer is still the same. And now I make instead a int one variable. I make a int array, and that means, well, how we create an array, I hope you know it. We are using this square brackets. In this square brackets, we have to write now how many numbers we want, elements we want. For example, let's say here for test purposes 3. And then you can use here this initializer list. We know this initializer list is allowed now to initialize directly values. That's nice. And I initialize, for example, here the values. Let's make it small, 1, 3, and 6, something like that. And you can see that is now created an array, a pointer who is pointing to an array and has initialized the value 1, 4, 6. And this is the, when we print an array out like this one, we know that an array here decays to a pointer. That's why we can make this one here. So we can assign an array, this one, to a pointer. We have talked about it. An array decays to a pointer. With other words, you can see when I hover my mouse over it, or can we see it? No, we can't see it here. But important is you have to know that this array becomes int pointer, also a pointer int here. And the point is, when you are printing this out with this differencing symbol here, you have to know, because this pointer is pointing to an array, and this pointer is pointing to the first element of the array. We learned this by the array and decay of pointers, which means it's pointing here to the first element, which means if I print this or start this program, we should get here the 1. Let's test this. If this is the case, yes, it is the case. But if you want to assign values now with this pointer, what you have to do is this expression, let's put this to our delayed. This belongs to this one here. What you have to do is just normal. You write here your, I don't know, pointer 1, and then you want assign. And how we assign this again? Here we can just use the array form if you want to assign anything. For example, the second value I want, I don't know, let's write this number for test purposes. And now important is why I can do this, because like I said, we have talked a little bit about it, a pointer, not too much, I think. We have not made too many examples, but we talked about it, that you can use a pointer and an array form here like this one. It's allowed because this decay of array and assignment and so on. And important is now the question how I print this one out. I hope you know it. How to print this one out. You can just use again the pointer version and say, okay, the pointer 2. All right, this one is 2. And let's see if this is working. And now there is something very important here. What did I do all time when I created this one? Do you realize? Yes, I hope you realize I created all time a memory leak. And why I created all time a memory leak? Because I used the wrong expression here, delayed expression. And because when you are using an array, you are using the square brackets here, and you need to use also this delayed array expression. If you're using, like me, this expression here, it says delayed, but this one is delaying only one value, so for a normal variable, not a non-array variable. And this one will cause a memory leak as well. So you have to add here, when you created an array, also this array symbol. Only then you are doing it right. And what it's saying here, yeah, it's gone. That was just, yeah, was not reacting. Now it's working. Now it's working. All right, and now I have no memory leak, and you can see it works with array as well. And I think it's now your turn that you read a little bit more about this kind of stuff on your own. That was just an introduction about the problems with new and delayed. There is much more to talk and more advanced topics, but I hope you understand a little bit of that. And important is that you understand this one here a little bit, that it is your responsibility now to release this memory. That's the biggest thing which you have to understand. When you create a new variable with new, it is similar to a normal variable, but it is your responsibility to release the storage here. And that makes it for many programmers really annoying, because like I said, you can cause easy memory leaks here. And one of the worst is probably this exception, because then this exception can even be occur when you use the delayed keyword, which you should all time use in combination, which means if you create new, write delayed as well. And most time before you go out of the scope of this created variable, because that's very important. But like I said, if there is an exception, this will be scope will be left, or there are some keywords which are also jumping out of the scope. Careful about this keywords go to or something like that, and can cause problems too. And I don't know, there are many ways to cause problems with this one. and you have to read this now in the documentation, research this online, read this in Good Enough C++ book. And the most important part is probably we will learn this unique pointer share, this smart pointers here, that we understand this one. But before we can understand this one, we have to learn this templates. But here I stop, and before I stop, there is something which I want to mention, and we start again a big exercise. Yes, we will start again a big exercise in our next videos, because it's time for us to train. We have talked a lot of theory, and for operators, this news here, and many things and classes, we have to repeat this. And I need to make many examples now, because we have only talked a little bit about them, so not in detail, and I said you should read all them on your own. And now I will try to find many examples, and then you have just to try to see if you understand it or not when I ask for it. So, and there is again a second part. We write, of course, in exercise a program again. So you try to, first we will try to write a program, and then we make this second part where I ask many questions again with examples. This is the way what we are doing in the next videos. It's time for training again. All right, with that said, if you have any questions or any suggestions, like all time, write it in the comments. See you in the next video with the exercises. And like all time, have fun, good luck, and never give up. Bye.